All right, my Algebra 1 students, here we go. We have some work to do on learning how to graph with slope-intercept form. And we're going to do a little bit of a review today on what it means to also calculate slope. Okay, so we have some slope-intercept form, we have some slope, and we have some graphing all in this video. So it might be a video you might have to watch more than once. You never know. You kind of have to keep at it to get all these different concepts down. Okay? One of the things that's going to be helpful is if you use pages 38 through 44 in your Algebra 1 workbook as we're thinking about this. And then a reminder right at the beginning of the video, and I'll remind you at the end as well, that I want you to complete pages 39, 41, and 43 in your workbook, and you're going to be showing that to me in class after you get those pages completed. Okay? All right, so let's start with this idea of slope. And we really need to remember, because you guys probably have worked with slope of a line before, that is going to be the rise over the run. Sometimes when we talk about slope in science, we call it the change in y with a triangle symbol meaning delta for change, delta y over delta x. That's another way to talk about slope. And the formula for slope is actually going to be based on 2 points. Okay, so what happens is we're going to be given 2 points. So let's say we have a point, we'll call it our blue point, is x sub 1, y sub 1, and it's somewhere on your graph. Let's say right here. So that point, we'll call it again our blue point right there, is at the coordinate 4, 2. Okay. And then a second point, and we'll call that point x sub 2, y sub 2, and that just stands for the second point. So the little 1 in the first coordinate just meant it was our first point. The little 2 down here as a subscript just means it's our second point. And let's pick a point. Let's pick a point right here. Let's pick 8, 5. 1, 2, 3, 4. Let's see. 1, 2, 3, 4, 5. Perfect. Right there. And that's the point 8, 5. Okay. So our slope formula actually is finding the difference in our y values, and usually we use our second y point and then subtract our first, but it really doesn't matter because you could designate either point as the first point or the second point. So the big thing here is that whatever y value we start with, we're going to start with the same x value on the bottom. So we're finding the change. Okay, this subtraction allows us to find the change in y and the change in x. So one thing you might notice, and one thing that might make it easier, is if I put in that we're going to put our green y sub 2 right there into that spot, and we're going to put our green x sub 2 into this first spot here. Okay, so let's go ahead and try this with our numbers. That is the official formula for slope. So let's first grab our y sub 2 value. You can tell it is lining up right there, so I know that one is 5. And then I'm going to subtract, just kind of keep going back and forth here between our green and our blue points. I'm going to subtract our other y value. There it is, right? 5 take away 2. And then on the bottom, again, because I started with my green, I'm going to come back to this point and grab my x value. And then I'm going to come back to my other point and grab that x value. And this is going to allow me to find the change in y and the change in x. So take a look what happens here with the numbers, and take a look what happens here with our picture. 5 take away 2 is 3. We know that's the change in y. And we can actually see 1, 2, 3 boxes right there along that y-axis. If I do 8 minus 4, that's going to be 4. That's my change in x. And I can see 1, 2, 3, 4 boxes there as my change in x. Now typically what we'll try and do as we're calculating slope, and I would recommend that you do this, is you try to go from left to right as you go across your coordinate plane. So we're looking for a rise of 1, 2, 3. So I go up 3. And a run of 1, 2, 3, 4 over 4. So that is a slope, a rise over run of 3/4. And you might also notice and make note that as you go up from left to right, that's a positive slope. So climbing up the mountain as you look from left to right, remember we're always reading our graph from left to right, this way, this way. This is shooting up the mountain. Okay, so that's going to be a positive slope. Okay, let's try another one. We'll try one with a negative slope here. Keep this in mind. Keep our equation for slope in mind as we move forward. Here we go. Let's try this one. I'm going to keep it close by right there. Okay, let's see. We'll try a first point. Let's try a first point right here at -2, 3. Okay, that's going to be my x sub 1, y sub 1. All right, and then let's try another point, maybe way over here at 7, 1. And this is going to be my x sub 2, y sub 2. Okay. And it doesn't matter which is which as long as if you start with 1 point for your x value, you're going to use that same corresponding y value as on the top. Okay, so let's give it a shot here. Let's plug things in. So I'm going to grab my y's, that one, and that one. All right, so it looks like this. It's going to look like, what, 1 minus 3. Okay, all divided by, and then I'm going to grab my x values. Again, whoops, wrong color. There's my x. I'll grab that one first to put there. And then I'm going to come over here and grab my other x value. Ooh, minus a -2. Okay, minus a negative. We're going to have to be careful of that when we calculate. All right, let's figure out what this is. 1 minus 3 is going to be a -2 in my numerator. 7 minus a -2, when I subtract my negative, remember that's going to be the same as adding a positive. So this is actually going to be 9, a -2/9. And this is my slope, and this means that as I travel from left to right, again, as I look this way, because my slope is negative, I should be going down from left to right. That's going to be a negative slope. Okay? It should be going this way, down, as I go from left to right across my board there, across my coordinate plane. So let's see if it actually is -2 over 9. We're going to go down 2 this time, and from this point, instead of going up 2, I'm going to go down 2 and over 1, 2, 3, 4, 5, 6, 7, 8, 9. In fact, it is a slope of -2/9, and you would just draw your line just like that going through that slope. All right, so now that we have an idea of slope, we can put that idea of slope together with graphing. Okay. Now, on the pages that you're going to be working through for your homework, you are going to see points like this where I want you to find the slope. And this is what I would like you to show me. I would like you to show me subtracting your y values. So I'll do one more here with you. So slope for number 5 is going to be 9 minus 3. And then next you want to grab your x values, and that is going to be 7 minus 10. Again, since I started with this point, I want to start with that point both on the top and the bottom, the numerator and the denominator. I get an answer of 6 over a negative 3. Now you can reduce this a little farther if you'd like to simplify for me. 6 divided by 3 is 2, and a positive divided by a negative is going to be a negative 2. And if you have to think of your rise over your run, think of it as negative 2 over 1 if we're going to be graphing that. So any integer that you have, like if you have 6, that can be written as 6 over 1. If you have 3, that can be written as 3 over 1. Right? If you have a negative 10, that can be negative 10 over 1. So all of your integers can be written as fractions, just like that. Okay? So that is calculating slope and what you'll be doing on part of your homework. The next piece of your homework is going to be to tackle this idea of the slope-intercept form of the equation. And it's called slope-intercept, so let's just write the word slope. Okay, and intercept. And that's going to be the y-intercept. And it's called slope-intercept form because in the equation itself, you need to have a slope. That's that variable right there. And a y-intercept, which is going to be that variable right there, in order to graph your equation. Okay, so typically, the way we can think about the slope is how your value is growing. Okay, it's like the growth number, it's the rate of change. Okay, it's the thing that's changing and creating growth or adding or subtracting the same number every time. The b value, the y-intercept, I like to think of it as your starting point. Okay, so a lot of times this will be like a base fee or how much money you start with in the bank before you start saving. It could be the number of points you have in a game before you start scoring, 3 points with every bucket, every couple minutes, whatever it happens to be. So I like to think of that b value as a starting point. Okay, so there's a lot of arrows, a lot going on there. This is going to be our number for slope. This is going to be our number for the y-intercept. So an example of an equation, we'll just do one right here, for y is equal to, let's say, 2/3 x plus 4. Okay, so what we'll do is we're going to grab that y-intercept, right? There's my y-intercept is a plus 4, and I'm going to count 1, 2, 3, 4, and put a dot. Okay, and then from this point, if I'm positive, I'm going up and then to the right. If I have a negative slope, I'm going to be going down and then to the right. This slope is positive, so I'm going to be going a rise of 2, up 2, so I'm going to count 2 boxes up and go over 1, 2, 3, and that is where I'm going to be drawing my line through those 2 points, just like that. So that is an example of graphing a slope-intercept form of your equation. Okay? So we're going to try it again, and we're going to do lots of practice with this, guys, so you get lots of extra practice. So don't worry if it seems a little tricky at first. We'll totally get it. But I do want to show you how we can use this idea of your growth number and your starting point on a problem in context. So I'm just going to write y is equal to mx plus b over here. So we can remember that we need to figure out our slope or our growth number, and we need to figure out our starting point. So let's read this together, and we'll do this one together, and then there's a different one you can do on your own in your workbook. It says, you and your friends go to the state fair. It costs $6 to get into the fair. That's a one-time fee, right? That's $6. I'm not going to get charged it again once I get into the fair. That seems like a good starting number, right? That's kind of my starting point, that base cost. But then once I get into the fair, $2 for each time I go on a ride, oh my gosh, that's going to start to get expensive, right? $2, not just once, not just twice, not just 3 times, but X number of times, some number of times that I'm going to go on a ride. So my variable X is going to be, right, it's going to represent number of rides, it looks like. Okay. So let's talk about how we could graph this on this picture. It looks like I'm going to need to figure out how many rides I'm going to go on, and I'm going to need to figure out how much money it's going to cost. And the amount of money depends on the number of rides. So this is your independent, and this is your dependent variable. That's very sciencey talk, right? So the number of money you spend depends on the number of rides that you are going to be taking, okay? So dependent and independent variables as you think about those values. $6. 1, 2, 3, 4, 5, $6. These are tiny little graphs. We'll put 1 right there, and 2 right there, and 3 right there, rides and so on. And it looks like for every ride I go on, I'm going to have to be charged $2 more, right? $2 more. My third ride, by that time I paid $6 more, and I have this increasing graph as I take a look at this situation. So my equation is my growth number of 2 times the number of rides plus my starting number of $6 to get into the fair. Okay, so the slope represents the cost per ride, right? It's the amount of money, $2 per 1 ride, right? There's your slope. What does the y-intercept represent? Oh, it represented that $6 fee that we got in on, right? That y-intercept represents the $6 for admission. Okay. Let's see what it says. How would you change the context so that the relationship between the total cost and the number of rides can be modeled just by y equals 2x? Well, that looks like $2 per ride. There's nothing added on, so I guess that would mean what? We get into the fair for free? So maybe we have free admission. Hooray! Free admission would change the context, right? So that we would not have to pay anything at the beginning. We would just have to pay $2 for ride. Our graph would then start at 0. It would still go up by $2 per ride, but our overall cost, of course, would be lower because we had free admission. We always like free admission. Okay, I hope this helped, guys. We'll see you in class. right? Stay after it. You're doing a good job.